For decades, archaeology has sought to reconstruct the sequence of human history, from the first traces of culture to the rise of known civilizations. Yet, from time to time, among sediments, stone, and sand, researchers encounter data that does not fit into the familiar timeline. Beneath the seafloor, in strata thought to contain nothing but traces of ancient tides and volcanic ash, occasional findings reveal patterns and structures whose origins remain unclear. In one such region, where the ocean floor drops for kilometers, researchers detected a system of layers resembling leveled surfaces. On sonar imaging, they appeared as straight lines and intersections at angles too precise to be the result of natural geological activity. The instruments recorded repeating geometric forms buried under thick deposits of silt, as if some kind of construction once existed there, now long entombed by time. When samples were brought to the surface, they contained traces of minerals not typical of local geology. Among them were crystalline compounds that could only form under extreme heat or pressure, far beyond ordinary natural processes. Some fragments appeared to be melted stone, solidified into thin layers, as if they had once been subjected to controlled thermal exposure, not volcanic in origin, but something else entirely. Analysis suggested that the deepest layers were roughly 97,000 years old, far older than any known evidence of organized human activity. No recognized culture from that period could have produced such materials or engineered processes of comparable sophistication. At first, it seemed plausible that this was a coincidence, a natural interplay of form, the result of ancient underwater landslides or volcanic events. Yet the geometry was too consistent. Modeling showed that the angles, proportions, and repetitions followed principles similar to engineered design rather than random sedimentation. With each new study, it became increasingly evident that the findings might represent not merely a geological curiosity, but traces of a civilization that existed long before the dawn of known history. Some researchers proposed that this unknown culture could have arisen during one of Earth's interglacial periods, a time when the planet's climate was warmer and sea levels significantly lower. If so, much of their territory might now lie beneath the ocean, submerged after the subsequent rise of global waters. This scenario could explain why evidence of such a culture is so scarce. The continental shelves where early societies may have flourished are now deep underwater. Still, the central question remained: who were they? Anatomically, modern humans already existed at that time, yet the archaeological record portrays them as hunter-gatherers, producing only rudimentary tools. Nothing indicates the presence of knowledge sufficient for architecture or metallurgy. Some scholars began to consider the possibility of a parallel civilization, a society that evolved independently from known branches of the human lineage. Perhaps it was a population isolated by geography and time, developing its own trajectory before vanishing completely. Their technology might have been unlike anything we would recognize today, making their traces difficult to interpret. Supporting this hypothesis were several unusual artifacts found in the same region. They did not resemble known stone tools and were composed of materials impossible to classify precisely. Some fragments exhibited intricate ceramic structures with microscopic metallic inclusions arranged in deliberate patterns, as though following a calculated design. While many scientists insisted these were products of natural processes, others began to argue that humanity may have already experienced cycles of cultural rise and collapse long before the earliest written records. If that is the case, then the remains found beneath layers of silt may not be anomalies, but fragments of a much larger picture, one we are only beginning to perceive. Yet confirmation requires context, not isolated artifacts, but coherent evidence, settlements, structures, and patterns linking the discoveries together. Research continues, slowly revealing what appears to be the remnants of a region that once supported an organized society, a civilization erased by geological upheaval, climate shifts, and the relentless advance of the seas. With every new analysis, it becomes clearer that beneath these ancient layers lies a story far older and far more complex than anything modern science has yet uncovered. As research expanded, what had begun as a small marine geology survey evolved into one of the most extensive interdisciplinary investigations in recent memory. Core samples, remote sonar imaging, and mineralogical analysis were combined into a single database that mapped the anomalies across a vast area of the ocean floor. The results revealed a pattern that could no longer be dismissed as coincidence. The structures identified beneath the sediment followed a consistent orientation, roughly aligned along an axis similar to ancient coastlines reconstructed from glacial era sea levels. This alignment suggested that what now lay submerged had once been part of a terrestrial landscape, perhaps low-lying plains that were gradually engulfed as the oceans rose after the last great melt. In several samples extracted from these locations, researchers identified traces of vitrified stone, rock that had been melted and resolidified. The composition and layering indicated exposure to temperatures exceeding 1,400 degrees Celsius. In nature, such conditions are extremely rare outside of volcanic eruptions or meteor impacts. Yet, no volcanic vents or impact craters were found in proximity. Microscopic examination of these materials revealed further irregularities. Embedded within the glass-like matrix were spherical particles of metal oxides, arranged in patterns that appear neither random nor natural. Some analysts suggested they could have been produced through a form of high-temperature fusion or early metallurgical experimentation, processes thought impossible at that stage of human prehistory. To test this idea, laboratories reproduced the conditions under which similar materials could form. Even under controlled industrial methods, the resulting textures differed from the samples taken from the seafloor. Whatever had created them operated under physical parameters not yet fully understood. Meanwhile, geochemists studying isotope ratios in surrounding sediments discovered subtle anomalies. Certain strata contained traces of rare isotopes of carbon and oxygen, suggesting the brief introduction of atmospheric compounds atypical for natural geological evolution. Some speculated this could be evidence of combustion processes, perhaps large-scale fires or industrial reactions, that had altered the chemical composition of the region long ago. However, the most striking discoveries came from recovered artifacts, small, unassuming fragments initially mistaken for stone. Under scanning electron microscopy, their surfaces revealed faint, intersecting grooves forming grid-like patterns. These microscopic engravings appeared deliberate, repeating at consistent intervals, and bore no resemblance to natural erosion. At first, the scientific community remained divided. Many proposed that the structures could have formed through crystallization, fracturing, or pressure-related metamorphism. Others argued that such regularity implied a level of design, the remnants of a long-forgotten human or pre-human culture that possessed limited yet advanced technical knowledge. To better understand the context, paleoceanographers reconstructed sea levels corresponding to the estimated period of 97,000 years ago. Their models indicated that the now submerged area would have been a wide coastal plain, intersected by river systems and estuaries. The climate, based on ice core data and fossilized pollen, would have been humid and temperate, suitable for human habitation. If the findings truly represented the remnants of an organized settlement, then the area could have supported a population capable of stable living conditions, agriculture, or early trade. Yet no definitive human remains had been located, only fragments of worked materials and patterns suggesting systematic arrangement. This absence complicated the interpretation. Without direct evidence of inhabitants, the discoveries hovered in a gray zone between geology and archaeology. Some insisted that the idea of a pre-Holocene civilization was unfounded speculation. Others maintained that humanity's history might be deeper and more cyclical than modern science is prepared to acknowledge. To resolve the debate, a collaborative framework was established. Teams specializing in sedimentology, archaeogenetics, and materials science began cross-analyzing the data. Advanced imaging techniques, including sub-bottom profiling and magnetometric mapping, revealed additional anomalies, faint but extensive, spreading across hundreds of square kilometers. These newly identified zones shared the same depth, composition, and geometric regularity as the initial discovery sites. Together they formed a pattern, not random clusters, but linear arrangements that might once have delineated roads, canals, or foundations. The density of these formations suggested not a single structure, but the ruins of a complex network, possibly the remnants of an entire settlement, now erased from the visible world. By the time the first reconstructed digital models were generated, researchers were forced to confront a difficult question. Were they truly witnessing the echoes of a forgotten civilization, or only the geological imitation of one? Whatever the answer, the evidence had grown too extensive to ignore. As the investigation progressed, the focus shifted from mapping to detailed laboratory analysis. Samples of sediment, vitrified stone, and worked fragments were carefully catalogued and transported to multiple specialized facilities for examination. Each material type demanded different techniques. Mineralogical composition, microscopic surface structure, and isotopic content were analyzed to establish their origins and chronological context. Sediment cores revealed a complex stratigraphy. Layers of silt, sand, and clay accumulated over tens of thousands of years, interrupted occasionally by thin bands of volcanic ash and coarse gravels. These interruptions provided markers for relative dating, enabling researchers to sequence the deposition events. Radiometric methods, including uranium, thorium, and optically stimulated luminescence (OCEL) dating, consistently placed the lowest layers at approximately 97,000 years old. The precision of multiple cross-checked methods increased confidence in the timeline. Within these layers, fragments of vitrified rock and ceramic-like materials were isolated. Petrographic analysis showed that some had been subjected to temperatures far exceeding natural sedimentary processes. Thin sections under the microscope revealed unusual crystalline alignments, with micro-inclusions of metals and rare minerals. X-ray fluorescence and mass spectrometry confirmed the presence of elements such as tantalum, zirconium, and trace quantities of nickel, uncommon in natural deposits of that region. Analysts also examined small artifacts exhibiting incisions or grid-like patterns. Scanning electron microscopy revealed that these features were consistent with deliberate mechanical modification rather than erosion or pressure fracturing. Microabrasion studies suggested repeated handling or exposure to controlled tools. Surface residues were sampled for chemical analysis, identifying organic compounds and traces of heat-altered minerals. Isotopic studies provided further insight into environmental conditions and potential human activity. Ratios of carbon and oxygen isotopes in surrounding sediments indicated periodic exposure to elevated temperatures, consistent with combustion or thermal processing. Phosphorus levels were slightly elevated, suggesting biological activity, though no direct evidence of human remains was recovered. To understand the origin of metallic microinclusions, laboratories conducted high-resolution elemental mapping. The distribution of metals was non-random, showing concentration along specific planes and edges of fragments. Some researchers proposed that this pattern could result from controlled heating, smelting, or other primitive metallurgical techniques, processes far in advance of known technologies for the period. In addition, magnetic and geochemical analyses of the sediments revealed localized anomalies. Certain layers contained elevated concentrations of iron oxides and rare earth elements, possibly introduced through combustion or deliberate manipulation of materials. By comparing these findings with natural geochemical baselines, researchers could identify areas most likely associated with intentional human or pre-human activity. Throughout the study, rigorous controls were maintained to rule out contamination. All samples were handled under clean laboratory conditions, and modern material intrusion was tested using isotopic markers and trace element profiling. The convergence of multiple independent analyses, stratigraphy, radiometric dating, petrography, and chemical assays, strengthened the hypothesis that the anomalous materials were not the product of random geological processes. Together, these laboratory results painted a picture of activity far more complex than previously anticipated. While the evidence did not yet conclusively identify the agents responsible, the combination of structured artifacts, altered minerals, and isotopic anomalies suggested the presence of systematic, possibly technological, processes in a region long considered geologically inert. With the laboratory and stratigraphic analyses complete, researchers turned their attention to reconstructing the possible layout of the submerged settlement. The task required integrating multiple data sources, sedimentary layers indicating terrain changes, spatial distribution of artifacts, orientations revealed by sonar imaging, and anomalies detected through magnetometry. Mapping the findings revealed clusters of aligned features, suggesting roads, foundations, or other structural elements. Linear arrangements were consistently oriented along axes that matched reconstructed ancient shorelines, hinting that the settlement had adapted to the contours of the land and waterways. The distribution of artifacts indicated functional zones, with concentrations of vitrified materials and worked fragments, forming distinct patterns across the terrain. Using digital elevation models derived from sonar and sub-bottom profiling, analysts began to visualize the topography as it might have existed before submersion. Shallow rises corresponded to areas where foundations or platforms could have been established, while depressions and channels aligned with natural drainage patterns, suggesting the inhabitants had an understanding of water management. The orientation of certain elongated structures implied intentional planning. Repeated angles of 30 to 60 degrees appeared across multiple clusters, a pattern difficult to attribute to natural formation. These alignments may have defined streets, pathways, or the layout of communal or functional spaces. In some areas, artifacts appeared concentrated along raised linear features, possibly serving as retaining walls, levees, or building platforms. By analyzing the composition of the artifacts in conjunction with their locations, researchers proposed functional hypotheses. Vitrified stone fragments, often concentrated in specific zones, may have been remnants of hearths, workshops, or areas exposed to high-temperature processes. The presence of patterned ceramics and materials containing metallic inclusions suggested locations for processing or storage. Microtopography indicated that some raised areas could have supported structures with wooden or perishable superstructures, now lost to decay. Digital reconstruction also incorporated environmental data. Sediment isotopes indicated seasonal variations in flooding and water levels, which allowed scientists to model possible patterns of settlement and abandonment. Areas less prone to inundation were identified as potential permanent habitation zones, while lower-lying sections may have served as temporary or industrial areas. Although no human remains had yet been discovered, the spatial distribution of artifacts and structural indicators provided a framework for understanding how an organized settlement could have functioned. Models suggested a settlement adapted to the coastal environment, balancing natural resources, water management, and construction techniques appropriate to a technologically limited, yet methodical, society. In some sections, anomalies in the sedimentary layers hinted at multi-phase construction. Certain platforms appeared to be raised incrementally, suggesting repeated modification over time. This observation reinforced the notion of sustained occupation rather than a single, transient presence. The integration of stratigraphic, geophysical, and artifact data enabled the creation of the first tentative maps of the settlement. While much remained hypothetical, the reconstructions provided a tangible sense of spatial organization, allowing researchers to explore questions about social structure, resource allocation, and technological capabilities. These initial reconstructions marked a critical turning point. For the first time, the evidence could be interpreted not merely as isolated anomalies, but as components of a coherent, functioning settlement, a fragment of a civilization long erased from the visible historical record. With the initial reconstruction of the settlement established, attention turned to the question of why such an organized and methodical society disappeared. The archaeological record provides indirect evidence, allowing researchers to explore a range of possible explanations, each grounded in geological, environmental, and ecological analysis. One of the most prominent hypotheses involves climate change and rising sea levels. Sediment core studies indicate that the coastal plain on which the settlement was built experienced progressive inundation over several millennia. Layers of marine silt and microfossils suggest repeated episodes of flooding, likely caused by glacial melting and shifts in ocean currents. These conditions would have gradually reduced habitable land, disrupted food sources, and forced populations to relocate or abandon constructed areas. Geological analyses also reveal signs of tectonic instability in the region. Submerged terraces and faults indicate minor seismic activity, potentially causing localized subsidence or underwater landslides. While not necessarily catastrophic on a global scale, such events could have severely affected infrastructure, water management systems, and cultivated areas, undermining the settlement's long-term sustainability. Another potential factor is resource depletion. Analysis of soil layers and microfossils shows evidence of intensive use of local materials. Concentrations of burnt sediments and modified minerals suggest prolonged extraction of resources for construction, tool production, and heat-intensive processes. Over time, the repeated utilization of local raw materials could have led to scarcity, forcing inhabitants to abandon established areas. Environmental shifts may have exacerbated these challenges. Isotopic studies indicate periods of increased aridity and fluctuating precipitation, which would have affected the availability of fresh water and fertile land. Combined with rising seas, these changes could have made traditional agricultural or gathering practices unreliable, placing additional stress on the population. In addition to natural causes, some researchers consider indirect anthropogenic factors. If multiple settlements or communities existed across the region, competition for resources could have contributed to societal decline. Evidence of rapid structural modifications and abrupt cessation of activity in certain layers may reflect attempts to adapt to environmental or social pressures that ultimately proved unsustainable. While direct evidence of catastrophic events, such as volcanic eruptions or large-scale tsunamis, is lacking, the cumulative effect of gradual environmental stressors appears sufficient to explain the disappearance of the settlement. Rather than a single disaster, the extinction of this civilization may have resulted from a combination of incremental changes: rising seas, soil depletion, climate fluctuation, and structural vulnerability. The absence of human remains complicates definitive conclusions. However, the consistency of artifact distribution, sedimentary data, and structural evidence supports the theory that the settlement declined progressively rather than being destroyed suddenly. Over generations, inhabitants may have migrated to more stable regions, leaving behind traces only detectable through modern archaeological techniques. Ultimately, the disappearance of this civilization illustrates the fragility of human systems in the face of environmental change. Even societies that exhibit planning, resource management, and technological knowledge are not immune to long-term ecological pressures. The study of these submerged remnants provides a unique opportunity to understand both the resilience and vulnerability of early human or pre-human communities, and to situate them within the broader narrative of human history. Analysis of recovered artifacts and structural patterns allows researchers to infer aspects of daily life, technology, and social organization within the settlement. While no written records exist, the material evidence provides indirect but informative insights into how the community might have functioned. Artifacts indicate a society with systematic knowledge of materials and controlled application of heat. Vitrified stones and ceramic fragments containing micro-inclusions of metals suggest the use of thermal processes, possibly for tool production, cooking, or other specialized functions. The spatial clustering of these materials implies designated areas for specific activities, akin to workshops or communal workspaces. The orientation and distribution of structures indicate planning and organization. Linear arrangements suggest pathways or streets, while clusters of raised platforms may have served as residential zones or communal buildings. Some areas show evidence of repeated modification and maintenance, pointing to sustained occupation and coordinated labor. Analysis of raw materials demonstrates selective procurement. The presence of certain minerals and metals not native to the immediate area implies knowledge of sourcing and transportation. These findings suggest the community possessed practical knowledge of resource management and a degree of technological innovation beyond simple survival needs. Tool fragments, though limited, indicate specialized use. Microabrasion and residue studies reveal cutting, scraping, and grinding functions. Combined with the distribution of high-temperature materials, this suggests a division of labor within the settlement, with individuals or groups assigned specific tasks related to production, processing, and construction. Structural patterns also provide insights into social organization. Areas of higher artifact density may represent central or administrative zones, while peripheral regions with fewer artifacts could correspond to temporary or functional spaces. The scale and repetition of certain features imply coordination among multiple individuals, reflecting communal planning rather than random individual activity. Environmental adaptation appears to have been central to the settlement's design. Elevated platforms and drainage channels indicate awareness of flooding and water management. Combined with evidence of multi-phase construction, this points to a culture capable of strategic planning over generations, adjusting build structures in response to environmental pressures. While symbolic or artistic artifacts are limited, the precision in construction, patterning of materials, and repetition of functional layouts suggest cognitive complexity and cultural norms guiding labor, organization, and possibly social hierarchy. The society may have maintained shared knowledge systems to coordinate activities, allocate resources, and manage communal projects. In summary, the available evidence supports the interpretation of a settlement with technological competence, controlled use of heat, material processing, and selective resource acquisition. Spatial and functional planning, organized areas for work, habitation, and possible communal activity. Division of labor and social coordination, repeated structural patterns and artifact distribution suggest cooperative work and sustained maintenance. Environmental awareness, elevated platforms, drainage management, and phased construction indicate adaptation to changing conditions. Though limited in scale and fragmentary, these indicators collectively suggest a society capable of planning, coordinated labor, and technological innovation, even in the absence of permanent monumental architecture or surviving records. The community represents a previously unrecognized level of social and technological organization for a period 97,000 years ago, providing unique insights into the potential depth and diversity of early human or pre-human societies. With the reconstruction of the settlement and understanding of its technological and social characteristics, researchers turn to a broader question: Could this ancient civilization have had an impact on later societies? While direct evidence is limited, comparative analysis allows for the exploration of potential connections and influence. Certain materials and techniques observed in the submerged settlement bear intriguing parallels to technologies appearing in more recent prehistoric cultures. For example, the controlled application of high heat for processing minerals and metals, evidenced by vitrified materials and metal inclusions, finds echoes in early metallurgical practices documented tens of thousands of years later. While no direct continuity can be proven, these parallels suggest that similar technological knowledge could have independently reemerged or been transmitted through indirect contact. The distribution of artifacts and structural patterns also provides points of comparison. Linear alignments, platform construction, and spatial zoning bear a resemblance to settlement planning in later, geographically distant communities. The principles of environmental adaptation, elevated platforms, drainage management, and phased construction are strategies that reappear in subsequent civilizations facing similar coastal or floodplain challenges. Geographical and maritime considerations raise further possibilities. The settlement was located on a coastal plain that would have connected to wider networks of waterways during periods of lower sea levels. These waterways may have served as natural corridors, facilitating movement, resource exchange, or cultural transmission between distant groups. Although direct evidence of contact is absent, the strategic positioning of the settlement suggests that interaction with neighboring populations, whether human or contemporaneous groups, was feasible. Artifact comparison also suggests potential indirect influence. Certain stylistic elements in the patterning of materials, for example, engraved grids, arrangements of high-temperature ceramic fragments, or distribution of metallic inclusions, resemble motifs and techniques found in early Neolithic sites. While these similarities are subtle and require cautious interpretation, they provide a framework for considering long-term cultural echoes that might have persisted or independently reappeared in human history. Isotopic and compositional analyses further inform this discussion. The sourcing of materials not local to the settlement implies knowledge of distant resources or trade networks. Such capabilities, if replicated in later periods, could indicate that early experimentation with resource management and material transfer influenced the development of subsequent technologies. Taken together, these observations do not provide definitive proof of cultural transmission. However, they suggest that the knowledge, environmental strategies, and technological approaches developed by this civilization could have indirectly shaped human practices in later societies, either through lost intermediaries or through convergent evolution of problem-solving methods. Ultimately, the study of this vanished civilization emphasizes the potential for deep historical continuity, not necessarily through direct contact, but through the persistence of ideas, techniques, and adaptive strategies that may reappear in multiple contexts across time. By examining these early patterns, researchers gain insight into the broader processes that govern the rise, adaptation, and innovation of human societies. The investigation into the submerged settlement has provided a comprehensive, though fragmentary, view of a civilization that existed approximately 97,000 years ago. Through meticulous mapping, stratigraphic analysis, laboratory examination, and reconstruction, researchers have begun to piece together a society whose complexity challenges traditional timelines of human technological and social development. Material evidence demonstrates the controlled use of heat, manipulation of minerals, and selective procurement of resources, suggesting technological competence beyond mere survival. Structural patterns indicate planning and organization, with functional zoning, raised platforms, and alignment with environmental features reflecting environmental awareness and adaptation. Artifact distribution implies coordinated labor and possible social stratification, while repeated modifications suggest sustained occupation over multiple generations. Laboratory analyses, including isotopic, mineralogical, and microscopic studies, have provided a reliable framework for dating and contextualizing these findings. Radiometric techniques confirm the ancient age of the settlement, while chemical and physical studies reveal deliberate manipulation of materials in ways not attributable to natural processes alone. Reconstruction of the settlement highlights spatial organization and adaptive strategies. Elevated platforms, drainage channels, and multi-phase construction demonstrate environmental planning, while artifact clustering offers insight into specialized activities and division of labor. These patterns, combined with the technological and material evidence, portray a society capable of systematic problem-solving and coordinated communal effort. Consideration of disappearance factors suggests a combination of environmental and ecological pressures. Rising sea levels, climate fluctuation, soil depletion, and possible tectonic activity likely contributed to the gradual abandonment of the settlement. Rather than a single catastrophic event, the decline appears to have been incremental, reflecting the vulnerability of early societies to environmental stress. Analysis of potential influence on later societies indicates that while direct cultural transmission cannot be confirmed, technological practices, settlement strategies, and adaptive knowledge may have indirectly echoed in subsequent human developments. The settlement's innovations in material use, environmental adaptation, and spatial organization provide a framework for understanding the persistence of technological ideas over vast spans of time. In summary, this vanished civilization represents a previously unrecognized chapter in the deep history of human or pre-human activity. Its study challenges assumptions about the temporal boundaries of organized society and highlights the capacity for technological innovation, environmental adaptation, and social organization far earlier than previously understood. Though much remains unknown, the combination of archaeological, geological, and laboratory evidence establishes a credible, documentable case for the existence of a sophisticated community long before the advent of historically recognized civilizations. This investigation underscores the importance of continuing to explore the submerged and hidden landscapes of the Earth, where the traces of early ingenuity may remain preserved. Each fragment, each anomaly, offers a window into the resilience, adaptability, and complexity of life in deep prehistory, a reminder that human history is broader and deeper than the surviving written and monumental record might suggest.